Hello everyone, welcome back to our channel. Let's discuss the next name reaction, that is Borch Reductive Amination. Let's see the statement. Reduction of amines by using sodium cyanoborohydride to form amines. By using this name reaction, we are going to prepare amines. What are the reactants here? Amines. Amines are converted into amines by treatment with sodium cyanoborohydride. We all know that the general formula of sodium borohydride is NaBH4. Here what we are doing, one of the hydrogen is replacing with Cn. NaCnBH3, sodium cyanoborohydride. Now the question is, how can we form the amines? Why? Because in this chemical reaction, the reactants are amines or ammonium salts. Right? If you see this equation, carbonyl compounds react with amines to form amines. So amines can be synthesized from the carbonyl compounds. Whatever the amine is formed here, that whenever treated with sodium cyanoborohydride to form the corresponding amine. Let's see the general equation. RC double bond OR. It is a carbonyl compound treated with amine. Simply what happened? This O and H removed in the form of OH and double bond takes place. And here the nitrogen is having 4 bonds. That's why positive charge is present on the nitrogen. Now we are giving the sodium cyanoborohydride. Sodium cyanoborohydride generates H- ion. The H- ion attacks at this carbon, thereby this pi bonding electrons move towards nitrogen, thereby we will come up with nitrogen. Simply what you need to remember, whenever the carbonyl compounds are treated with amines in presence of the sodium cyanoborohydride, simply what you do, whatever the carbon is present in the carbonyl compound, here pi bond is present or not, convert that pi bond into single bond and connect the nitrogen. See this, pi bond is converted into single bond, here it is the nitrogen, then valency is satisfied. Okay, if you see the mechanism, in the mechanism what happens? Initially nitrogen donating its lone pair electrons to the carbon, thereby these pi bonding electrons move towards oxygen, oxygen will take the minus charge. So we are forming a bond with carbon and nitrogen. Nitrogen is losing the electrons, means nitrogen will take positive charge or not. That's why what happens, these single bonding electrons move towards nitrogen to neutralize the positive charge. So hydrogen is removed in the form of H plus, the H plus is moved towards O minus. So we will come up with OH minus. Now the nitrogen lone pair again forming a pi bond removes the OH minus. Thereby we are getting iminium ion. This is treating with sodium cyanoborohydride. Sodium cyanoborohydride generates H minus ion. So this H minus ion is approaching this carbon, thereby these pi bonding electrons move towards nitrogen. So nitrogen will take the minus charge, the positive and negative charge will be neutralized. So we will come up with the product. Okay, let's see some of the applications of this reaction. Here it is a ketone. Ketone is treating with amine to form imine in presence of TiCl4, triethylamine and DCM. Simply what happened? H2 and O removed in the form of H2O. So pi bond is formed between carbon and nitrogen. Now it is treated with NaCnBH3, that is Borch Reductive Amination. So simply what happens? The pi bond is converted into single bond. Pi bond is converted into single bond. Okay. See the next example. Here we have C double bond OH and secondary amine. InCl3 in presence of NaCnBH. Whenever you have NaCnBH3, so you should remember that reaction is Borch Reductive Amination reaction. Okay, simply what you need to do, whatever the carbon is there, that can be converted into carbon nitrogen single bond. See, carbon nitrogen single bond. Now satisfies the valency of the nitrogen. Satisfy the valency of nitrogen. Okay. If 2 carbonyl groups are present in a molecule, what happens? Cyclization phenomena takes place. That's why see, cyclic ring has been formed here. So initially what happened? One carbonyl group and one amino group involving in the reaction, just removal of H2O to produce double bond and imine is formed. Here we have HCl, thereby nitrogen donates its lone pair electrons to H plus, so it can produce iminium ion. Okay. Now it is treating with sodium cyanoborohydride, means it is a Borch reductive amination reaction. H minus is approaching here, thereby we are getting the neutralization of nitrogen here. So if you see this moiety, in this moiety again carbonyl group is present and nitrogen is present. So both carbonyl group and amine are present in this molecule. So again second time Borch reductive amination takes place. So nitrogen again losing lone pair electron, the hydrogen is approaches here, OH is there, again nitrogen losing lone pair electron, pi bond formation is there, then it is the imine type 1. Now it is treated with NaC and BH3, you will come up with final product. So 2 times Borch reductive amination takes place. Okay. Here also similar kind of situation, directly we are writing. Before discussing the application, if you see the first they have given NaIO4, HiO4, NaI4. These are the oxidizing agents. Oxidizing agents are useful for the conversion of the diols into corresponding carbonyl compounds. So this is the diol or not? That's why what happens, the diol is initially converted into corresponding aldehyde. Okay, so 2 aldehydes are present or not? Here benzyl amine is present, see this. Here 2 keto groups are present and amine is there. So 2 times Borch amination takes place. That's why cyclization phenomena observed here. So here also similar situation, see this. 2 aldehydes are there. That's why 2 equivalents of NaC and BH3 is produces. That's why here the cyclic ring formation takes place with nitrogen. Very simple. So in this way, you need to remember the Borch reductive amination, conversion of the imines into the corresponding amines. In most of the cases, whenever we have 2 carbonyl groups, we will come up with the cyclic product. Okay, thank you very much.